On this problem, we have 5 Snickers and 4 Twix, and we're told that we want to choose 2 to eat. Now, if you're choosing 2 to eat, it must be without replacement because it's not like you can eat one and then put it back. Okay. And we want to find the chance that at least one is Snickers. Well, there's multiple ways you can do this problem. I think it'd be beneficial to, as far as our understanding, this isn't something that you're going to normally do every time you do this problem. Let's look at all the possible outcomes. Okay, again, this part is more to help us conceptually than what you have to do when you do this problem on your homework. So if I was to pick 2, and there's Snickers and Twix, I could get Snickers and Snickers. I could get Snickers first and then Twix. I could get Twix and then Snickers. Or I could get Twix and Twix. So if you think about it for a minute, those are the only possible outcomes. There are only 4 possible outcomes that you can choose from. Okay, so now let's find the probability of at least 1 Snickers. So just you would think about, okay, well, what are the possible outcomes up here that have at least 1 Snickers in them? So I could get Snickers and Snickers. I could get Snickers and Twix, or I could get Twix and Snickers. Any of those would work. So if you have a situation where any would work, you're going to want to find each of those individual probabilities and then add them up. Or if I want to write out, this would be the probability of Snickers and Snickers. Or, so I kind of like to put a little bit of space to say these are grouped together. Snickers and Twix, again, those are grouped together. Or Twix and Snickers. So the thing is, any of those combinations will give me what I want. Any of those combinations will give me at least 1 Snickers. Okay, now to find those probabilities, to get a Snickers and a Snickers, when you see and, you have to times. So Snickers and Snickers. The first time there are 5 Snickers out of 9 total. But then I ate 1 Snickers, so now if I want another Snickers, there would only be 4 Snickers out of 8 total. Okay, so that gives you the and part. But now for or, you're going to put a big plus. Okay, so Snickers and Twix, if I want a Snickers first, there's going to be 5 out of 9. Then when I want a Twix, well, there are 4 Twixes out of 9. Sorry, out of 8 candy bars total. It is unfortunate that these actually end up giving you the same thing, okay? And that was just coincidence because if you eat 1 Snickers, you have 4 Snickers left, or you have 4 Twix left. Okay, we do a plus for the or, and then Twix, there are 4 out of 9 Twixes, and then I want a Snickers, there will still be 5 Snickers out of 8 total. So remember, your denominator drops here because you already ate a candy bar, so there's less total. Okay, so again, we multiply for the and so we're like, we can get this one, or we can get this one, or we can get this one. Any of those 3 work. So we multiplied for the and, Snickers and Snickers. And then after we found each of those little combinations, we added them all together because we're like, we could do this one, or this one, or this one. And that gives you something. It's on the key. I did not bring in my calculator in here. So you can look at the key to see what that actually is. Okay, so that's one way you can do it. That's the long way because notice we had to find 3 different probabilities. You can also use the complement rule. Now, anytime you see the keywords at least 1, you can use the complement rule to save time. Now, you don't necessarily have to use the complement rule unless we get to much bigger, more complicated problems, which we don't usually do in this class. Because you can always just find each of the outcomes by hand and add them all up. But the complement rule saves time. The complement rule says, instead of knowing that I'm going to have to add up 3 of those, we realize that anytime it says at least 1, there will only be 1 option left over. The only option left over will always be none. Okay, so if you know that all probabilities have to add up to 100%, or 1 if you're working with fractions or decimals, and 3 of them were good for us, but only 1 wasn't what we wanted. you can always do the probability of at least one Snickers is going to be equal to 1 minus the probability of no Snickers. Or none Snickers. Because that was the only thing left over that we didn't want. So the probability of no Snickers meant you actually have to get Twix and Twix. So to get Twix and Twix, the first time you have 4 Twixes out of 9. The second time you only have 3 Twixes out of 8. And if you put that in your calculator, you're going to get the exact same thing that we did up above. Again, the complement rule just saves you time because they realize if you want a probability of at least 1, the only thing left over would be the probability of no or none. And so that just saves you time. Again, you can do it either way. It's just up to you and whether or not you remember that you'll save time if you use the complement rule.